This video is going to be a little longer than most of them that I usually make. We're going to talk about trigonometric identities and using them to simplify expressions, as well as establishing trigonometric identities. So let's start off with these first couple. And I see that the bottom there is going to be able to be multiplied by 1 minus sine theta to be able to simplify it. So this is going to be cosine theta times 1 minus sine theta over 1 minus sine squared theta. So plus tan theta over here is going to give me cosine theta 1 minus sine theta over cosine squared theta. One of the cosines is going to cancel, and that's going to give me 1 over cosine minus sine over cosine plus tangent. 1 over cosine is secant. Sine over cosine is tangent. And a negative tangent and a positive cotangent make a 0. And this simplifies down to be secant. Now we have 1 plus cotangent theta times 1 minus cotangent theta minus cosecant squared theta. So this is going to turn into 1 minus cotangent squared theta minus cosecant squared theta. Remember that 1 plus cotangent squared is equal to cosecant squared. So if I have a cosecant squared, I can make that into 1 plus cotangent squared, like so. 1 minus cotangent squared minus 1 minus cotangent squared is going to be 1 minus 1 is 0, and this is a negative 2 cotangent squared theta. Now let's work on establishing some of these identities, completing them down here. So if I have secant theta minus 1 over secant theta, I'm going to make a common denominator and make this secant squared theta minus 1 over secant theta. So 1 plus tangent squared theta equals secant squared theta. So secant squared theta minus 1 is tangent squared. This is tangent squared theta over secant theta. There's really nothing that I can do to simplify that. If I wanted to change it into sines and cosines, I could say that that's sine squared over cosine cubed. But that's just as good. Now we have cosecant theta times sine theta plus cosine theta. So this is going to be cosecant times sine is going to be 1. This is cosine over sine, which is cotangent. That's all they want us to do there. This one where we have sine over 1 plus sine minus sine over 1 minus sine. They want us to make a common denominator. And multiply 1 plus sine times 1 minus sine. And then the denominator, we get a 1 minus sine squared, which is a cosine squared. And at the top here, we get sine minus sine squared minus sine minus sine squared is going to be sine minus sine is 0. This is a -2 sine squared. Sine squared over cosine squared is tangent squared. Sine over cosine plus cosine over sine is going to be sine squared plus cosine squared over sine times cosine is going to be 1 over sine times cosine. This is really close to a double angle identity, so I'm going to multiply that by 2 over 2 to get 2 over sine of 2 theta and make this 2 cosecant of 2 theta. Number 7, tangent squared theta minus 3 sine theta tan theta secant theta is equal to what? So sine over cosine is going to be tangent. So this is tangent squared theta minus 3 tan squared theta is equal to a -2 tan squared theta. Nothing more to be done there. Sine theta plus cosine theta quantity squared over 1 plus 2 sine theta cosine theta. The numerator is going to be sine squared theta plus 2 sine theta cosine theta plus cosine squared theta over 1 plus 2 sine theta cosine theta. Sine squared plus cosine squared is 1. And we have the same thing in the top and the bottom. So this is exactly equal to 1. 1 over cosine squared minus 1 over cotangent squared is going to be a 1 minus cosine squared minus a sine squared over a cosine squared, because the reciprocal of cotangent squared is tangent squared, which is sine squared over cosine squared. This is 1 minus sine squared over cosine squared, which is cosine squared over cosine squared, which is 1. Two tan theta minus 1 plus tan theta quantity squared. 2 tan theta minus 1 plus 2 tan theta plus tan squared theta. It's going to be 2 tan theta minus 1 minus 2 tan theta minus tan squared theta. So this is going to be a negative on the outside. 1 plus tan squared theta is a negative secant squared theta. We have tan theta, it's cotangent theta minus cosine of theta. It's going to be 1 minus, and then this is going to be sine over cosine times cosine. Cosines will cancel. It's going to give me 1 minus sine. Now we have secant theta sine theta over tan theta minus 1 is going to be sine over cosine is tangent over tangent. 1 minus 1 is 0. Sine squared theta minus 1 over sine theta plus 1. Break this down using the difference of two squares. This factor will cancel and leave me with sine theta minus 1. Have secant to the fourth theta minus 2 secant squared theta tan squared theta plus tan to the fourth theta is equal to, so this should be a perfect square, secant squared theta minus tan squared theta. 1 plus tan, this is squared, plus tan squared equals secant squared. So secant squared minus tangent squared is equal to 1. So this is 1 squared is 1. Cosecant of theta times sine squared theta plus cosine squared theta tan theta over sine theta plus cosine of theta. So let's go ahead and multiply through by a cosecant here, or 1 over sine here. That's going to give me sine theta plus cosine over sine is cotangent. That's going to leave me with a cosine times cotangent times tangent is 1. Sine over sine plus cosine here. I have the same thing top and bottom, and that's 1. Now I have a sine squared theta plus sine squared theta cotangent squared theta. So I'm going to pull sine squared out, make 1 plus cotangent squared, which is sine squared times cosecant squared. And these are reciprocals of one another, so that's 1. Secant to the fourth theta plus secant squared theta tangent squared theta minus 2 tan to the fourth theta. So this one's a little different than before. Let's go ahead and try and change let's split that middle term up here. Let's try and do this. So let's say secant to the fourth theta minus a secant squared theta tan squared theta plus a 2 secant squared theta tan squared theta minus 2 tan to the fourth theta. And let's try and factor by grouping. So secant squared theta, secant squared theta minus tan squared theta plus a 2 tan squared theta times a secant squared theta minus a tan squared theta, and secant squared theta minus tan squared theta times secant squared theta plus 2 tan squared theta. So secant squared is 1 plus tan squared minus tan squared. So that's just a 1. I don't need to worry about that one. And then secant squared theta plus 2 tan squared theta. So secant squared is 1 plus tan squared plus 2 tan squared. It's going to be 1 plus tan cubed. And that's simplified because I've gotten everything down in terms of one trig function there. So that's ideally what I want to do. Now I want tan to the fourth theta minus secant to the fourth theta. So this is a difference of squares. Tan squared theta minus secant squared theta times tan squared theta plus secant squared theta. We've already gone through this. 1 plus tangent squared is secant squared minus 1 minus tan squared. So we get a -1 here, and tan squared plus 1 plus tan squared is going to give me a -1 times 1 plus 2 tan squared is a -1 minus 2 tan squared. All right, let's clear that. Cosecant, cotangent over secant. Let's take the reciprocals of these things to help us out. So cosecant is 1 over sine. Cotangent is cosine over sine times cosine over 1. The reciprocal of the denominator is going to be a cosine squared over a sine squared. It's going to be a cotangent squared. Now we've got 1 over cotangent squared plus secant times cosine is going to be 1 over cotangent squared plus 1. This 1 plus cotangent squared over cotangent squared is going to be 1 plus cotangent squared is cosecant squared over cotangent squared. Actually, let's make this tan squared plus 1. 1 plus tangent squared is secant squared. That's better. There we go. Cosine of theta minus cosine of theta sine squared of theta is cosine of theta times 1 minus sine squared. Be cosine times cosine squared. It's going to be cosine cubed. Sine squared plus tan squared plus cosine squared is 1 plus tan squared is secant squared. Seven plus sine plus 7 plus 7 sine over -5 cosine is going to be 7 times -7/5 times 1 plus sine over cosine. I could then make this into secant plus tangent. Let's see if I can make this, let's see if this helps. Nope, that's not going to help to put it down there in the bottom. So let's just make this secant plus tangent. They actually want us to multiply by the conjugate here. I just checked. 7/5, 1 minus sine squared over cosine times 1 minus sine is going to be -7/5 cosine squared over cosine times 1 minus sine is going to be -7 cosine over 5 minus 5 sine, something like that. All right, here's the last couple here. ln of cotangent, the ln of cosine over sine. So we use our log properties to write that as ln of cosine minus ln of sine, like that. Remember your absolute value bars. And for the last one right now, ln of cosecant. Cosecant is the reciprocal of sine. So if I think of that as sine raised to the -1st power, not inverse sine, but sine to the -1st, then this can come out as a -1 ln of sine, like that. All right, that's it for this video. Sorry that one was a little bit longer, but there's all different types of identity techniques, and there was no easy way to just split it up into the different types of techniques, so just did them all in one video. So hopefully that was helpful to see all those different types of examples, and we'll see you for the next video.